Imagine a future where the lines between our physical world and digital experiences blur so completely. Businesses rethink nearly everything they do. That's precisely the promise and controversy surrounding spatial computing. Experts say this rapidly evolving technology could spark profound business innovation and expansion. But how much is hype, and how much is real opportunity? Let's break it down, with some surprises along the way. Spatial computing gathers ideas and breakthroughs from multiple tech domains to produce truly immersive, interactive environments where humans and machines collaborate in unprecedented ways. Businesses across the globe are waking up to its potential, eager to tap into new growth avenues, boost productivity, and diversify their offerings. What exactly is spatial computing? At its most fundamental, it's the virtualization of interactions between people, machines, objects, and their settings. The term was introduced by MIT grad Simon Greenwald in his 2003 thesis, describing spatial computing as human-machine engagement that relies on the machine's ability to understand and manipulate real-world references and locations. Greenwald envisioned technologies that make our devices capable partners in both work and leisure, a viewpoint that remains as relevant as ever. But here's where it gets controversial. Spatial computing isn't just about basic virtual interactions anymore. New tools let us weave digital and physical realities together in powerful new ways. Unlike traditional computing, which thinks in flat, two-dimensional spreadsheets and screens, spatial computing works with 3D data tied to real environments. Companies like TheBlue.ai point out that this is made possible using data from IoT sensors, 3D models, advanced analytics, and computer vision. Tools like volumetric cameras gather 3D location data, allowing devices and applications to understand and interact with actual spaces. Essentially, digital information is no longer separate from the physical world. It's layered into it, often instantly. Maciej Versky of Deloitte observes that spatial computing turns business data into easy-to-grasp real-world context, making even complex technical topics more approachable. Employees in supply chain, marketing, engineering, and beyond can engage with data in intuitive, hands-on ways, something traditional software often fails to provide. Interest in spatial computing is skyrocketing. Companies in manufacturing, warehousing, and office management are flocking to it for a variety of goals, from streamlining logistics to improving workplace collaboration. On the workforce front, immersive simulations are transforming training. Employees can practice real-world scenarios, developing skills that go far beyond what conventional modules offer. Imagine airlines using VR to safely train pilots in simulated emergencies, or hospitals teaching doctors intricate procedures in risk-free environments. That's spatial computing in action. And this is the part most people miss. Simulation isn't just for employees. Powerful spatial computing software lets businesses model and test operational strategies before rolling them out, anticipating bottlenecks and optimizing outcomes. Deloitte's Tech Trends 2025 suggests that integrating artificial intelligence (AI) with spatial data will soon offer seamless, predictive experiences where AI agents anticipate what users need even before being asked. AI, in fact, stands at the heart of spatial computing. Already, it analyzes real-time 3D data to interpret environments, improve decision-making, and predict outcomes. Take the example from Onerix, an AR company. Their solutions fuse AI with 3D data, helping users analyze everything from machinery performance to foot traffic flows, crucial insights for business. Now, what about robots? Here's where things spark some debate. The blending of spatial computing, AI, and robotics means robots can be trained using virtual environments to navigate and interact with the physical world with razor-sharp precision. NVIDIA highlights advances in XR, teleoperation, and digital twins, virtual clones of real spaces that let robots operate in dynamic settings, opening doors for automation beyond manufacturing into retail, logistics, and even healthcare. The immersive impact goes further with virtual reality VR. VR powers lifelike environments for training, collaboration, and even client demos. For instance, airlines create ultra-realistic flight simulators, while the medical field uses VR to prepare doctors for surgery or emergency situations. Augmented reality AR is subtly changing everyday business too. By overlaying digital instructions or visuals on real equipment, technicians can perform complex repairs faster and with greater accuracy. Gaming is the popular face of AR, but it's spilling into navigation, maintenance, and education. Then there's mixed reality, MR, which merges AR and VR, letting users interact with digital models within their real settings. Think architects previewing building designs before ever breaking ground, catching costly mistakes before they happen. Digital twins deserve a special mention. By creating a virtual replica of a physical entity, like a vast warehouse, production line, or city block, businesses can analyze, optimize, and even forecast outcomes with a fine degree of control. NVIDIA describes how new rendering technologies bring real-world data into spatial computing devices, supporting training, teamwork, and creativity in extended reality XR environments. PwC, one of the world's leading consultancies, highlights 4 core areas where spatial computing is already delivering tangible business value. 1. Process optimization. Smarter interfaces help users test designs as digital twins or get instant feedback through AR, streamlining everything from prototyping to daily operations. 2. Brand and community engagement. Virtual spaces offer marketers new ways to reach audiences and spark growth, as seen in online conferences. Virtual showrooms and immersive ad experiences. 3. Employee experience. Immersive environments amp up productivity, focus, and team spirit while making onboarding and skill building more effective and enjoyable. 4. Revenue diversification. Spatial computing unlocks entirely new income streams, whether through customer-facing platforms or collaborative product development. All of this is translating into staggering market growth. According to the latest findings from Precedence Research, the global market for spatial computing has already hit $149.59 billion in 2024, and that's just the beginning. By 2034, projections soar to $1,066.13 billion at a blazing 21.7% compound annual growth rate, CAGR. North America leads the pack with a commanding 32% market share, cementing itself as a hub for tech innovation. With giants like Microsoft, Google, Apple, Facebook, and Magic Leap investing heavily, the region is a magnet for both industry veterans and agile startups. Silicon Valley, Seattle, and Boston foster intense competition, new breakthroughs, and ever greater market interest. But here comes another twist. Asia-Pacific APAC is catching up fast, clocking a projected CAGR of 22.2%. Why? High smartphone ownership in China and India is driving demand for mobile-based spatial computing apps. Mobile AR experiences, whether in gaming, retail, or education, are exploding in popularity, and the market growth is tracking right along with them. Despite all this momentum, there are real and controversial obstacles. Gartner draws attention to head-mounted displays, HMDs, essential for spatial computing immersion, but still plagued by high cost, clunky design, and poor battery life. For many users, these devices are uncomfortable and isolating, hardly ideal for everyday business or public settings. Could this